Hey guys, talking to you today about chemical equations. So here's an example of a chemical equation. You'll see usually the symbols, a whole bunch of symbols for, like, in this case, like that's the symbol for carbon, that's the symbol for oxygen, hydrogen, oxygen, and so forth, okay? And then you'll see sometimes numbers, and that just tells you how many of each thing that we need, okay? This one tells you how many of this blob, and these little numbers tell you how many of each individual thing is inside of a blob, okay, or a section, or what they call a molecule, okay. Let me explain what I'm talking about. So if you see, like, let's say, okay, let's just take a look at just this one. Ignore the 6 on it. Let's just look at this one. H2O. That is one hydrogen and oxygen combined. You guys know what H2O is. It just means water. In this case, we need, for this formula has 6 waters in it, okay? And when it says water, it means, when it says like 6 waters, it means 6 water molecules. Well, let's take a look at what a water molecule is. It's H2, and then an O. H2 and an O, okay? A water molecule is a hydrogen, that stands for hydrogen, and oxygen. But this little 2 means 2 of those. So 2 hydrogens and an oxygen, okay? So let's take a look at I'm going to show you an example of a water molecule. Okay, so I've got an oxygen atom, sorry, too far over, an oxygen atom, and it's a number 8, so it's got 8 electrons, okay? You can't see it because I'm covering it. 8 electrons for an oxygen atom, okay? H2O, so here's my oxygen, and H2, we have 1 hydrogen, that's an H, that's H2, that's 2 hydrogens. Okay, so H2O, where is it? H2O, okay, ignore the 6 right now. H2O means 2 hydrogens and 1 oxygen. So 2 hydrogens, okay, 2 hydrogens and 1 oxygen, all stuck together. That right there is 1 molecule of water. Okay, that's 1 molecule of water, right? So let's take a look at another molecule. What about this one on the end? It's just O2. It's at 6 in front of it, but it's just O2. What this one is oxygen. Oxygen by itself a lot of times likes to group up into little pairs. So what you end up with floating in the air, this is actually what you breathe, is these 2 little oxygen atoms just kind of bonded together, stuck together, Remember we talked about how they share their electrons? These guys are sharing these electrons because this one has a couple of different spots open, and this one has some spots open, and so they just kind of share their electrons, okay? That's O2 right there. 2 oxygen atoms stuck together, O2. Okay, let's look at another one. Let's do CO2, carbon dioxide. Di means 2, carbon dioxide. Carbon dioxide, CO2. All right, let's do CO2. So here's a carbon, okay? A carbon is number 6, okay? So it's got some spots on the outside, CO2. Just 1 C. Let's take our oxygens. Let's look at the formula. Carbon dioxide, ignore the 6. We got CO2. C, just 1 of them, and O2. That means there's 2 of these ones. If it's by itself, it doesn't have a number, it means it's just 1. CO2. So let's do a C, and 2 O's. That's carbon dioxide right there. So I showed you water, I showed you carbon dioxide, and now I've got, so this is CO2, and the other one was carbon dioxide, or sorry, water. That one's carbon dioxide. Okay. By the way, it's carbon dioxide. That's why it's called that. Okay. All right, so now let's take a look at this. Let's ignore this part. Let's just look at this part of the formula right here. Okay, so formulas a lot of times, well, let me explain first what it is. Formulas a lot of times will have 2 sides, almost like, and they'll have either an arrow or an equal sign. It means this goes into that, or this turns into that, with, in this case, sunlight. Okay, if you add light. Sometimes it's if you add heat. Sometimes it's just if you add time. Sometimes it's just if you even let them touch, then let these two touch, then it creates this. Sometimes it's just a matter of exposing these together and it creates that. So it just depends on the formula, depends on what it is. I don't know if you've ever noticed reactions where like it doesn't even have a second to think. It just, as soon as the two molecules, whatever they are, touch, and it just explodes or does its reaction. Okay, this is the stuff that makes the reactions, are what makes the cool things happen in chemistry classes. People are always asking me every year, we're going to blow things up. Well, probably not, but if you were an official chemist, you could learn how to take two chemicals and combine them, and then it turns into something else that's usually an explosion, or not usually, sometimes an explosion, or sometimes heat, or sometimes nothing, or whatever. Okay. Anyway, so let's take a look at this part. Okay. In this case, if I take 6 carbon dioxides, 6 CO2s, plus 6 water molecules. So if I take 6 carbon dioxide molecules, this is a picture of a carbon dioxide molecule, by the way, and 6 water molecules, if I take 6 of these and 6 of these, then if I add some sunlight or light of some sort, it turns into this. It turns into sugar and oxygen. This is basically glucose. It's a type of sugar. It's what's found in plants. Okay. So if I take 6 carbon dioxides, which is the air that we breathe out, and 6 waters, and I add some sunlight, and the plant has to know how to do it, but it'll turn into this. Plants literally take carbon dioxide, the air we breathe out, mix it with water. That's why plants need water, and they turn it into sugar. That's what they eat. Plants don't actually eat, but they absorb the nutrients and they create their sugar. They actually use the sugars to live off of. And then that's why we eat the plants, because we get the glucose and stuff from them, which now, because sugar is basically energy for us, that our body uses it to get energy out of it, because our body does another reaction where it gets energy. Anyway, but this right here, this is basically carbon dioxide, the air we breathe out, plus waters, creates a sugar molecule that the plant uses, or that we use if we eat it, or the cow eats it and uses it, whatever. Okay, the sugar molecule where we get the energy from, and some oxygen. And so if you notice, have you ever heard of the term photosynthesis, where the plants take in carbon dioxide and they do their process and they release oxygen? Have you ever heard that? People take in oxygen and put out carbon dioxide. Plants do the opposite. They take in carbon dioxide and they put out oxygen. That's why we like plants, because it gives us oxygen to breathe. Okay? Because of this. 6 carbon dioxides and 6 waters turns into a sugar and 6 oxygens. Let me show you this in picture format, and I'm going to put my screen way down so you can see. I'm going to have to get something to do it on top of. Okay, here we go. So there you go. Hopefully you can see that. I'll put it down just a little bit more. Okay, so basically so what I did, and you're going to see this in your in class, basically, I took this worksheet, okay, and there's that formula I showed you about, and what I did is I took this entire thing, I took the formula, and I created all of the atoms. 6 carbon dioxides, which means 6 of these, and 6 of those, but that's 2, so it's 12 of those, 6 of hydrogens, 6 of 2 hydrogens, so that's 12, 6 oxygens, and so forth. I created I basically, it's all of these atoms, and then I went through and I cut them out. These right here are all of the atoms inside one of this reaction. All of these atoms, okay, these are all part of it, plus the sunlight. Okay, this is all the ingredients that takes, just like cooking. You have ingredients, you have to put them together, plus heat of some sort, in this case sunlight, and it creates a reaction. It cooks something. Cooking is a reaction. You've got the things that you put together, and then if you add heat, they turn into something else. Okay, that's exactly what's happening. So I took this right here, because of the way the formula works. Remember, there's 6 carbon dioxide molecules. So I did 6 carbon dioxide molecules, and I just broke them up and drew them apart, and I cut them up, and 6 waters, okay? And then I'm going to show you how it creates the other, okay? So I'm going to put this formula up here so you can see it. I don't know why. I get it to show more. Oh, yeah. Okay, so what I'm going to do is I'm going to take I'm going to create 6 carbon dioxide molecules. Okay, so carbon, so 6 carbon dioxide. So carbon is just 1 and oxygen's 2. So there's 2 oxygens. And here's my carbon. Can you see it? There we go. Okay, so I got to create 6 of these. There's my carbon and there's my 2 oxygens. That's 1 carbon dioxide molecule. I need to do 6 of them. So that's another dioxide, so 2 oxygens. And I'll find my carbon. There's a carbon, so that's 2 of them. Okay, I need 6 altogether. So this is just not working very well. Let me just put this down here. Let's see. Sorry that you can't really see it very okay. All right, so it kind of fell apart. Anyway, okay, so that's my 6 carbon dioxides. Okay, now I'm going to take another, oh, no, sorry, that's 2. That's 2 carbon dioxides. I need to make 6 of them because the formula calls for 6 carbon dioxides. Ah, stop falling off, stupid thing. I should have created tape on these. Let me just, hang on. Scoot these up a little bit. Okay. All right, so now I'm going to do another one because I need 6. So that's 2 oxygens and a carbon. Carbon dioxide, okay? So that's 3. Now I need to do 3 more. So I'm just going to do it pretty kind of fast, these ones. Okay, there's 2 oxygens. And let's find my carbons. There's a carbon. Okay, so that's 4. I need 2 more. There's an oxygen, 2 oxygens, and a carbon. Okay, that's 5. I need 2 more. I need 1 more. There's a carbon, and there's an oxygen. Okay, I have the first ingredient for my equation for photosynthesis, for my recipe for sugar. Okay, I have my in oxygen. So I take 6 CO2s, and I need to add 6 H2Os. So let me add my waters. H2, so H2, I need 2 hydrogens and a water. An oxygen, sorry. 2 hydrogens and an oxygen. There's another water right there. Okay, 2 hydrogens and an oxygen. Okay, so I've got 3 waters and 6 carbon dioxides. I'm going to scoot that one over a little bit. Okay, so 2 hydrogens and an oxygen, H2O. 1, 2, 3, 4 of them. 2 hydrogens and an oxygen. 5 of them. 2 hydrogens and where's my other oxygen? There it is. And an oxygen. Okay, so I've got all of my ingredients. Okay, I've got all of my ingredients to make sugar and oxygen, except I have to add light. So I'm going to come around and I'm going to shine some light on my ingredients. Okay, I have to cook them basically. So I'm going to create some light. I'm going to shine some light on all these ingredients. Okay, and now they're going to magically turn into this and this. And I'm going to build it for you, but let me just kind of explain why that happens. Is if you add heat, it causes these elements and atoms to move around and to interact with each other, and it creates it just basically realigns itself. It kind of just creates this difference. Okay, so I've got all my ingredients, and if you'll notice, when it cooks, I don't add anything new. I'm just rearranging them. Because like I said, when you add the energy, the sunlight, when you quote, cook them, it just rearranges them. So let me show you what that is. So let me show you with the same ingredients. I'm going to move around a little bit. With the same ingredients, we're going to create these. Okay, so I'm going to create the sugar. So I've got C6. Notice there's no big number in front of it. It just makes 1. So C6. So I'm going to find my C's. Okay, the C there, a C there, a C there. That's 3 of them. 4, 5, and where's my 5th one? I mean my sixth one. Oh, right here. Okay, so this is my, all right, my carbon, oops, that's not it. Okay, this one. There you go. All right, so I've got 6 carbons right here. I'm actually going to sit this aside just a little bit. Okay, yeah, it's not going to work very well with me showing you on both things, but I'm going to try my best. So I'm actually going to, you've seen all of these kind of grouped together. Let me just kind of scoot them. Okay, they're being rearranged because of the sunlight. Being rearranged. Now I have C6H12O2. So I have 6 carbons. Okay, here's all my 6 carbons right here. Here's my 6 carbons. Okay, that's 6 carbons. And the next, in the same molecule, I have 12 H's. So I got to find my H's. 1, 2, 3. There's 3, 4, 5, 6, 7, 8. This is not working very well. 9, 10. If I can get them with my fingers. 9, 10, 11. One more in here somewhere. Where's my other one? There it is. Okay, 12. And if I were to look in there, there wouldn't be any more. So I've got C6. Okay, C6. 6 carbons. 12 H's. And I need 6 oxygens. This is what sugar looks like. This molecule right here is actually sugar. 1, 2, 3, 4, 5, 6. Okay, if you lay it all out perfectly, that is sugar right there. That's the ingredient for glucose. Okay, now notice there's leftovers. It didn't need all of it. It had all these. It took these, but it has leftover oxygens. It doesn't need them. It doesn't need them to create the sugar. It only needed 6 of them. I've got all of these oxygens left over. Guess what they do? They make this one. They pair up, and we end up with 1 pair, 2 pairs, remember oxygen 2, 3 pairs, 4 pairs, 5 pairs, and 6 pairs. 6 oxygens pairs. Oops, 6 oxygen pairs. So what I did is I took those, added light, and I ended up with sugar and 6 pairs of oxygen. That's how it takes carbon dioxide, water, and it creates food or energy like sugar and oxygens. That's why photosynthesis takes carbon dioxide out of the air, also uses water, and turns into sugar and oxygen. That's how plants operate. That's why we get energy. Okay, that is the formula. So I know that was a little bit long, but I wanted to explain how it all works together. Just remember, this big number tells you how many molecules, and the little number tells you how many of each atom are inside of that molecule. Okay, and then it tells you on whatever side of the equation it is, it tells you this will turn into that. Usually it will tell you what it needs inside there first to do that. Okay, it's like a little recipe. All right. Hopefully that made sense. If it does not, please ask questions, and I will answer them as best as I can. I can do a quick Zoom with you, or I can do just handwritten, typed up answers, whatever you prefer. Okay, so let me know if you have any questions. Thank you.